Hello and welcome to this short instruction video on the 1G Dike experiment. This video is part of a series of introductory videos on soil testing and physical modeling produced by the section of Geo-Engineering at Delft University of Technology. This video is meant to provide an insight on the 1G Dike experiment as performed in the course Experimental Methods in Geotechnical Engineering at TU Delft. The main goal of this video is to illustrate the use of small-scale models to understand the behavior of a dike subjected to a hydraulic gradient. More specifically, we would like to get an impression of the flow in the body of the dike. This goal is achieved by releasing 3 patches of food coloring at various locations on the upstream side and monitor the streamlines. The video is composed of 2 parts. The first part presents a brief introduction about some details of the test, such as geometric dimensions and the setup. Some questions will also be presented to trigger thinking about various aspects of the experiment. We will explain in detail how the test will be performed step by step in the second part of the video. First, let us have a look at the geometry and various soil types forming this model dike. The width of the model dike, that is the dimension perpendicular to the screen, is 51 mm. There are 2 buffer containers on either side of the model. The main body of the dike is built with coarse-grained sand with the grain size ranging from 1 to 2 mm. During the test, a pump will be used to maintain a constant water head between the upstream and the downstream side of the dike. The aim of this test is to show you how water flows through a dike body. This is done by injecting food coloring to visualize the streamlines of the flow. You could draw a flow net for this problem first, and you will see that the path of the ink resembles closely the streamlines of the theoretical flow net. As you can see, the scaled model of the dike is built in a transparent storing box. The pump is connected through a hose on the upstream buffer compartment and water can flow through the sand body. Filter layers consisting of layers of gravel with different grain sizes were placed on both sides of the model to protect the sand from being washed away. On the upstream side, the water level is clearly visible as it lies just below the crest of the dike level, and on the right hand side the water level is just above or on the same height as the filter layer. Before going through the details of the test, let's think about some questions. These are questions that you should be able to answer after performing the experiment. How to measure the discharge in the setup, how to estimate the permeability of the dike material, and how to verify the estimated value of the permeability using the flow net and the measured discharge. And to continue, how to extrapolate the observations and measurements to a 100 times larger prototype, and how will the flow net the discharge through the dike and pore water pressure, for example, under the crest of the dike change if the same test was performed at 100 G in a centrifuge. Now let us take a look at how we conduct the experiment. In this experiment, ink will be injected to visualize 3 streamlines through the dike. Drops of ink are released at the locations along the water side of the dike. 1 at the toe of the dike, 1 at approximately 2/3 of the height from the bottom, and the third one in between. In this video, we also injected 1 more drop of ink just below the water table. Here's a screenshot of the experiment. As you can see from the screenshot, the trajectory of the ink flowing through the dike can be identified. Based on this trajectory, you can approximate the streamlines of your flow net. As the next step, we would like to have an approximation of the total discharge through the dike. To do this, we need to measure the drop in water level with time when the pump has stopped. Knowing the cross-sectional area of the left compartment, we can calculate the volume of water which has been discharged over a certain period of time. For example, we read the water drop delta H after 3 seconds. Then we can calculate the discharge using the equations listed in this table. And this wraps up the content on the 1G Dike experiment. Make sure to watch the other instruction videos as well to have a more comprehensive understanding. On behalf of the section of Geo-Engineering at Delft University of Technology, we thank you for paying attention to this video. We wish you good luck with your studies.